Hello, this is Professor Meiskens again. I'm going to give you a demonstration of some of the things that you're going to encounter in lab when you're doing a titration, and that will be in week for lab 5 and also other weeks when we're using a pH meter. So you have here in view is a pH meter. Right now it's showing a reading of 3.92, and this pH probe is on an adjustable holder, so it can be moved in lots of different positions. And right now it's sitting in some storage solution, which is where you might find it when you're coming into lab. And I'm going to show you how to use this, and we're going to check a pH 7 buffer to see how close we are. That's something you'll do when you're in the lab, and it will illustrate some of the ways that you should keep in mind as you handle a pH probe. And then you'll see how this gets used in the lab when you do a titration. I also have a burette here, and I'll do one example of making a reading off the burette where we're looking for trying to measure things to, in some cases, up to 4 significant figures. So that's another important part of the lab. So let's focus on the pH meter. And this probe that's in here, you can see I can lift it up out of the storage solution. I can show you up a little more closely with this other probe here and get it kind of close in. And this probe is built with, at the very bottom, a very thin glass membrane, and that's set up so they can accurately measure pH. But because that membrane is very thin, you have to be careful not to do damage to it, to not let it hit the bottom of, let's say, the beaker or other places where you have it mounted. So that's what the probe looks like, and then we get a readout. So for lab, we want to first just check and see if this pH probe and pH meter is giving us reasonable values. So we're going to check that against the pH 7 buffer. So you'll find also when you come to lab that there is a green solution in a beaker, and this will be the pH 7 buffer, and it's unmistakable from other liquids because it's colored green. And this is the bottle that it comes from, pH 7. It's made up to be a reference solution. So I want to lift my probe out of the storage solution and set that aside. I'm going to put a waste beaker underneath my probe, and I'm going to take a squirt bottle and I'm going to rinse it. The squirt bottle has deionized water, and that just rinses off the storage solution off of the probe. And we can take a Kim White and we can just gently kind of take off the excess water from this probe. Put that waste beaker aside, and we're going to set it into our pH 7 buffer. So I don't want to set it so far that it crashes into the bottom, but I want it to be well immersed in my liquid. And now I'm going to show you that I'm just going to do a kind of a chemist's swirl, which is to move the beaker in a circular motion, and that keeps the fluid at the exposure of this membrane at the bottom of the probe fresh all the time. And what we're interested in seeing is how close does the reading come to what we expect, which is 7.0. And right now you can see it's reading 6.97, and I'm swirling it. It seems pretty stable, and that's a great result. So that's what I would write down on a report sheet, 6.97. So we're not going to try to adjust it to 7.0. We certainly are going to say that's close enough. And if you find a value that's very different from 7, you can bring that to the attention of your instructor, but we're generally going to end up not making any changes, but just noting what that value is. And fortunately, in this case, we got something very close to what we expect. So we don't need to change anything about this probe. I'm going to right now set it back in its storage buffer, storage solution. So this probe is ready to go. You probably will end up in lab once it looks good, set it up so that it's sitting in the beaker that you're going to do a titration, which would be at the bottom of your burette, and on a stir plate, so that you can use a magnetic stirrer to keep the solution stirring while you're doing the titration. So the other thing I want to show you is that we are going to be using a burette, and I wanted to do an example of reading volume off of this burette. And Professor Feinweaver has told you that the markings on this burette are to the nearest tenth of an ml. So you can certainly see which marking your meniscus is closest to, but you can also read in between the lines and estimate between lines, which allows you to read things to the nearest hundredth of a milliliter. And once your volume becomes more than 10 mLs, then you have a 4 significant digit reading on your volume. So I have a piece of paper here, and I'm going to put a couple black marks on this so it looks like this. And I'm going to use that to highlight the meniscus, and I'm going to see that this meniscus is I'm going to locate where it is. Now you have to pay attention to where the values are on the burette, and I'll give you a closer look of this in a moment. So this is between 9 and 10, so it's going to be something between 9 and 10. And I see the meniscus is very much in between two readings on here. And the burette is set up so that for every ml, the line around the burette goes entirely around the cylinder of the burette. So you can actually tell easily whether you're looking straight at the burette or not. And this is all to try to get that high precision out of your burette. And so when I look at this and I see that it's between 9.7 and 9.8, and it's about halfway between those, I can say 9.75 for my reading. And I'm going to give you a chance to look at that a little more closely. So that's the illustration, and we want to have everybody get a chance to be able to make a reading on your burette to that level. So let me take this out of the stand, and we'll get up really close to this and see if this is going to focus well enough to give you the reading that I just discussed with you. Can we see there's a 9 and a 10, and you can see that this value comes right in between 9.7 and 9.8, and you can see where that highlights that meniscus. So that's what we would like you to be able to do, is to take those accurate readings on a burette as part of this skills that you're learning in this titration experiment that you're going to do. So that's all for this particular demo video.